Before the experiment, we need to calibrate the instrument. First, we open the software, click LabChart 8 on the desktop. After opening, there will be a check mark prompting us that the Power Lab has been connected to the computer. Here is a software upgrade reminder here, which we can cancel directly. This is the Welcome Center interface. It displays the most recent experimental files, etc. If you don't need it to be displayed every time you open the software, just click Show Welcome Center at Startup in the lower left corner. Close the Welcome interface. A signal display interface will pop up. The software supports up to 8 channels. Since our instrument has 4 channels, we will modify the number of channels first. First, click Setup in the upper left corner and select Channel Setting. The first 4 channels are checked here because the software recognizes that our instrument has 4 channels. In the lower left corner of this interface, you can modify the number of channels displayed. This can be modified from 1 to 4 according to the number of channels you actually use. The software interface now has 4 channels. Here we demonstrate displaying 1 channel. Look, now it shows 1 channel. Next, we calibrate the instrument. First, we need to set the instrument's range according to the tension range to be measured. This is the display range. 10 volt is a bit too high. We changed it to the customary 100 millivolts, which is the experience value. Click Start. As you can see, the signal is wavy. We can make the signal smoother by modifying the digital filter. Click Channel 1, select Digital Filter, and change the cutoff frequency to 10 Hz. The signal will not have as much jitter in the y-axis direction. Now our hardware is without any load weight, and the value measured by the instrument is about 0.2 millivolts. Later in the calibration process, we will change the voltage unit to the mechanical unit millinewton. Before calibration, we need to turn the big knob to lift the arm. Use the small knob here to remove a bracket. Now the bracket is unloaded and the software displays the value. Now return to the software interface. Under zero load, the voltage is about 0.25 millivolts. Record this value first. Next, we mount the weight that comes with the device on the connector of the tension sensor. Here is a 20-gram weight. Then read the value in the software interface. The current value is about 12.70 millivolts. Record this value and the corresponding weight in grams. Now let's pause the signal reading and click Stop. Click the channel and select Unit Conversion. First, select the unit to be converted. Under Unit, there is no millinewton that we need to convert. Let's customize the unit here. Select milli for prefix and enter N for the unit on the keyboard. Enter the two values we just recorded. When it was just negative 0.26 millivolts, the corresponding force was 0 millinewtons. There is another value. When 12.7 millivolts was measured just now, the corresponding weight was 20 grams, which is about 196 millinewtons. Click OK. Click to start recording the signal. The unit displayed now is millinewton. Because there is still a 20-gram weight hanging on the hook, the current display is 196 millinewtons. To verify that the unit conversion was successful, we can remove the 20-gram weight and replace it with a 50-gram weight. Theoretically, it corresponds to the value of 490 millinewtons. Let's see if this is the case. We have hung up the 50-gram weight and adjusted the height. Now go back to the software to see if it is the value of 50 grams. As you can see, the measured value is about 490 millinewtons. This means that our calibration is complete. We can set the result of this calibration as a default configuration. The next time the software is opened, it will run according to the standard set this time. Click Edit in the upper left corner, select Default Setting, and click Save. A file called Document1 will be created here, and this configuration will be used by default the next time it is opened. If you want to load a new configuration next time, you can click the default setting just now, click Revert, and the saved configuration will be deleted. The calibration weights just now can be replaced with other standard weights. 10 grams or 20 grams are both fine, and the standard process is the same. After calibration, put the hook back in. Tighten the small knob. Next, we will use a simulated tissue to demonstrate the experiment. We first hang the tissue on the hook. By adjusting the knob on the arm, we adjust the distance between the hooks. After the tissue is mounted, we use the large knob to immerse the entire tissue in the bath. Flip the switch to refill the bath. If you need to inject air, you can turn the knob of the air pump to open it. You can see that air has been injected into the bathtub, and the flow rate of air injection can be adjusted by turning the knob. At this point, our experimental preparation phase is over. After the hardware preparation is completed, return to the software interface and click to start the experiment. This is the change in tension after the tissue is suspended. If the experiment is over, we can click Stop to end the experiment. Click the upper left corner and click Save as to save the file in a specific folder for result analysis. If we want to analyze the data, we need to use the DatePad function of the software. There is a DatePad icon here. Click to open it. The DatePad window will appear. Click the split window on the layout to display the data window and signal window. Now let's look at the upper window. Channel 1 now shows the maximum value. Clicking on Channel 1 will display other data, such as the mean, median, standard deviation, etc. Here we click on the mean value, select it, and click OK. Click on the plus sign window under the data pad, and the mean value will be displayed. This is the mean value of the entire experiment. If we only want the maximum value of a section or part, we first select the area with the mouse, click on Channel 1, and then click on the plus sign under the data pad. The maximum value of this stage is calculated. Repeat the operation once, select this section with the mouse, and then click the plus sign under the data pad. If you want to export this data, you can first select the data, right-click, and then click Copy so that you can paste the desired data into a table. Click Save, and this is the data we are going to analyze. This is the process of calibration, experiment, and result analysis of this instrument. If you have any questions, please contact us.